In case of feedstock extrusion, the main challenge that we experience is to maintain the accuracy in line. So in this project work, we have used the fingerprint philosophy. In fingerprint philosophy, it is based on increasing the production yield by reducing the post-processing or offline metrology effort while maintaining the accuracy in line. So in this project, we have used both product fingerprint and process fingerprint. And the product fingerprint is based on each manufacturing step or process will result in a unique dimensional outcome or a surface topology or a form error on the produced component, which is called the manufacturing product fingerprint. And by controlling the product fingerprint and maintaining in the required limit, the product quality can be maintained. And another concept is for process fingerprint. And the idea of process fingerprint is to identify and monitor the selected process parameters which exactly influence the product variation to maintain the production of product complying to the specifications. In case of extrusion of bi-lumen tubes using feedstock, the main product fingerprint candidates that we have considered here are external diameter of the tubes, internal diameter of lumens, the roundness of the tube, and roundness of lumens, and lumen center point distance, and the area of extrusion, and also the surface roughness of the tube. And the flowchart of the methodology used is given here, like a DOE campaign is carried out by varying the extrusion parameters, and the fingerprint candidates are measured. Then statistical analysis carried out in order to find out the product fingerprint features which has a highest sensitivity to the process variation, and then a correlation analysis between the product fingerprint candidates are carried out, and a ranking is given based on this correlation, so that by controlling the product fingerprint candidates with the highest correlation, the all product features can be maintained in the limit. So from this statistical and correlation analysis, the product fingerprint is found out. Then an optimum process conditions are applied, and these optimum process conditions can be found out using a multi-objective optimization methodology. And by maintaining this product and process fingerprint in line, the quality of the product can be maintained. And we can get the bi-lumen tube of required quality and required accuracy in the required tolerance limit by extrusion. The extruder that we use for our study is a screw extruder, and feedstock is put through this hopper, and it will go through this extruder, and it will be extruded through a water bath, and finally we can get a bi-lumen tube. The process parameters in case of extrusion of feedstock are screw revolution speed or velocity. The screw will be here, the screw revolution speed, and the second one is temperature of extrusion. And we have applied the temperatures here, like T1 to T9, and which is considered as a single parameter, and which is another extrusion parameter. And this is a die that we use for our extrusion experiment. And the material that we used is 17 PHG 120E by polyamine. And these are the extrusion parameters that we use. We have used 4 levels of temperature and 4 levels of RPM, 4 levels of extrusion velocity for 3 replications. So 48 experiments are conducted by extruding a bi-lumen tube of length 400 millimeter.